Security models and architectures try to address the system's vulnerabilities and issues, however not all architectures are totally secure. Some of the common architecture issues include covered channels, design flaws, programming issues, timing issues, process integration, and electromagnetic radiations. Covered channels are used to send information over a path that is not usually used for communication, which could be unsecured and compromised by unauthorized users. These channels could be used to violate or bypass a security policy. There are two types of covered channels. Covered timing channel can reveal the data sensitivity by monitoring the system's resources usage timing, while the covered storage channel reveals information by writing it to a common area that could be read by another process. Although they are very hard to detect, audit trails should be analyzed for any covered channel activities. Design flaws and poor coding techniques are weaknesses that could lead to attacks. For example, special entry points added to the code during development could become backdoors if not removed before moving to production. Extensive testing of the code should be performed, including separate security testing. Some of the design issues include failure states, parameter checking, maintenance hooks, and incremental attacks. Failure states occur when a system crashes and recovers, where several systems might clear the security controls, which would present an opportunity for an attacker. For example, if a system crashes while classified transactions are being written to the database, then an unauthorized user might have a temporary access to the data. The same issue might be faced when a system recovers, so it is recommended to do a trusted recovery, where access is prohibited even if the security controls are disabled. Parameter and input checking issues occur when the programmer does not properly validate the input data. Input data is usually stored in a buffer, but if an attacker types an amount of data that exceeds the input buffer, then the extra data is considered to be overflow. This allows for a type of attack known as buffer overflow, which allows an attacker to execute malicious code as part of the program input. Programmers are required to check and limit all inputs and parameters before allowing them to be stored in any data structure. Maintenance hooks are developer entry points to the system, to guarantee access when necessary. However, if an attacker got to know of these backdoors, they could perform malicious activities without even being detected. Incremental attacks are performed by attackers in a small incremental manner to avoid being detected, such as the salami attack, and data diddling. The salami attack typically targets financial accounts, where very small amounts of the balances are deducted regularly, to avoid being noticed. Data diddling is when an attacker makes small changes to the data, instead of fully manipulating and deleting files. Programming issues occur when the program can't handle exceptions, and could get into an unstable state. Such cases could lead to program crashes, and might allow attackers to compromise the data during this time. Timing issues occur when an attacker is capable of predicting the task execution on a system, where there is a time gap between when a subject checks and actually uses an object. The attacker might be capable of manipulating the object that the subject uses during this time gap. Process integration issues occur when new processes or technologies are introduced, where the security status of the architecture is still unknown. Finally, electromagnetic radiations could be intercepted by attackers, giving them the capability of recreating the original content, and the best way to reduce this risk is by using shielded cables, and ensuring the physical security of the devices and facilities.